Hi everyone, welcome back to Prieto TV and Happy New Year! We go on to Prietology again. This is episode 5 of season 2. Today's topic, like I said last class, is radioactivity. We have 6 key terms today, so other than that, let's get started. Alright, so let's review our key terms that we have. So we have 6 terms for today. We have radioactivity, alpha particle, beta particle, photon, Schrödinger, what a fun word to say, Schrödinger's cat, and weak force, one of the fundamental forces of the universe. So let's start with our first term. Alright, so let's start with our first term, radioactivity. Radioactivity is the action that happens when atoms break down, so basically when they collapse on themselves. Radioactivity can affect atoms with more than 83 electrons because remember, I think we talked about this in season 1, the number of protons of the element is also the atomic number of the element. So elements number 82, so uranium and below, so uranium to hydrogen, those are all naturally stable except for a little few radioactive ones, one in there. But 83 and above, those are all radioactive and are subject to radioactivity. Radioactivity is usually a battle between electromagnetism, which we'll talk about next class, and strong force. Both are fundamental forces in the universe. This makes a nucleus split apart and emit alpha particles, beta particles, and destructive gamma rays. We learned about gamma rays when we talked about waves 2 classes ago. They're very, very high energy and can cause cancer and split DNA. So fun fact, radioactivity was actually discovered in 1896. So the discovery of radioactivity has actually been around for a pretty long time. Alright, so we are on to our second term, alpha particles, or alpha particle. Like I said last time, this is one of the results of radioactivity. This is the largest particle in nuclear radiation, and this can be stopped by something as thin as a sheet of paper. So a little piece of paper can stop an alpha particle. This can be slow moving and very destructive. It's not as fast moving as beta particle. It's very slow moving and, like I said, can be destructive. This is also known as a very heavy helium nucleus. So imagine a nucleus, a helium atom. It's just a nucleus. That's an alpha particle. Just a nucleus of a helium atom. So the fun fact about alpha particles is its weight is 6.644656 times 10 to the negative 27 kilograms. That, on a scientific scale, is pretty big. Alright, so our third term we're almost halfway through, is beta particle. Beta particle is basically almost the opposite of an alpha particle. This is a very fast moving particle, unlike its partner alpha particle, which is a very slow moving one. This is actually an electron, a very speedy, highly charged electron. It's negative charge without a nucleus, so it's basically just a random it's basically just as scientists say, free electron that's whizzing around in the air without a nucleus attached to it. This is 7,000 times lighter than the alpha particle, which is a huge scale, and this can be stopped by something as thin as a little sheet of metal. So a thin sheet of metal is able to stop a beta particle, but that's a lot more compared to a thin sheet of paper. Fun fact, the mass of this is 9.109 times 10 to the negative 31 kilograms. You might think, hey, 9 for the beta particle is greater than 6 for the alpha particle. Why this is lighter is because of the exponent that goes with it. I think I said beta particle was somewhere around negative 26, 10 to the power of negative 26, and this one is 10 to the negative 31. So the negative 31 makes it smaller, much, much smaller than the alpha particle. Alright, so on to our next term, which is the fourth term, photon. Photon is the fundamental particle of all waves in the universe. So microwaves, infrared waves, radio, light, gamma, infrared, every wave out there is made of photons. Photons, here's a bit of quantum physics for you. Photon is the quantum of light. Quantum means basically it's basic particle. So light is made of photons, so photon is the light's quantum. This is usually shot out of radioactive nuclei as gamma rays, very high energy photons. These can also be listed as gamma particles, so there's alpha, beta, and gamma particles. But mostly people like to call them gamma rays because it's much simpler. So a photon, a high energy photon, is a gamma particle. This is the fastest thing in the universe because this has no mass and is the speed of light, which is the fastest thing. Fun fact, this actually uses another thing in quantum physics called wave-particle duality. Wave-particle duality means this can act as a wave and a particle at the same time. I think, I'm not an expert at wave-particle duality. Quantum physics is a weird thing. So basically this can be a wave and a particle at the same time. One, because a photon is a particle. And two, photons make waves, I think. I'm not sure. This is also, I think a photon is also on the standard model. Here's a picture of the standard model right here. I think it's on it. Oh well. I think it's in a category where on my standard model that's over there, I think it's in a group called force carrying exchange particles. So that's basically the same group that another one, the carrier of weak force, is in. So we'll get to weak force in a while. Alright, so our fifth term is really some quantum weirdness for you. It's called Schrodinger's cat. I don't know if you heard about this, but this is a thought experiment. This is a hypothetical experiment that you're not supposed to do in real life because that would be animal abuse. The thing about the experiment, the context of the experiment, so there's a cat in a box with some poisonous gas and some radioactive material. If the radioactive material decays enough, it'll swing a hammer that'll crack the bottle, which is, I think, is full of cyanide gas, that will release the gas everywhere. Supposedly could be killing the cat in the box. But the thing about the experiment, you don't know if the cat is dead or alive until you open the box. You can't be just like, oh, the cat is dead. But you can't be positively sure that the cat is dead before you look into the box. It's quantum weirdness for you. So, like I said, this explains the mysteries of the quantum world, which I know almost nothing about. So the results of this experiment, well, the thought results, not the physical results, don't do this. The results show that there could be two different realities at the same time. So the results of the experiment is that the cat is dead nor alive. So it's neither both, or dead and alive at the same time. I'm not sure. So, fun fact, this is thought in 1935 by Erwin Schrödinger, which is the person that put this. Alright, so we are on to our final term, our sixth term, weak force. This is one of the fundamental forces in the universe. So far, in this season, we talked about three. We've talked about gravity, strong force, and weak force. There are four fundamental forces. We will get to the last one next week. So this is the force of attraction between quarks, neutrinos, and electrons. This creates fusion and fission. So basically, this is kind of like an extension of strong force, but for little tiny particles. But this, despite its name, it's not the weakest fundamental force. This is 1 billion trillion times stronger than gravity. So you could say that gravity is the weakest force, and I'm guessing this is the second weakest force. The range of that weak force can work in, remember the range is how much the force can be applied to. It can be applied to 10 to the negative 18 meters. So this has to apply in very small spaces. Fun fact, the carrier, or the particle that carries it throughout the universe, is the W positive, W negative, and Z0 particles. These are also known as the weak bosons, which are in the same family group as the photon, which is, like we heard, is the quantum fundamental particle of light. So these, like I said, are force-carrying exchange particles. So I think we covered all our key terms for today, so let's get to the announcements. I don't have an experiment for today. Well, editing is a struggle sometimes, so the outro film was corrupted, so we're gonna do the outro here. Alright, so announcements. Next week is the final episode of Season 2 of Prietology. We are done with the second season. So, Season 2 ends, we're done with physics episodes after next week, and the topic will be electricity and magnetism. We're going to end the season with electricity. So we're going to talk about the final fundamental force, which we haven't talked about, which is electromagnetism. And then we'll get into electronics, current, inductors. I don't think we're going to get that deep, but conductors, insulators, current, voltage, generators, electromagnetism. So yeah, that should be fun to do. Also, second announcement, Cuphead will start next week, so stay tuned for that. Well, thank you for watching, and if you like this video, leave a like and consider subscribing. See ya.